Okay. So bending moment at D. So what will be the value? 190 into 6 minus 30 into 6 into 6 by 2 minus 60 into 4. How much this will come out?
360, sir.
360. So this is minus or plus?
Positive.
Okay.
Plus.
Okay. 360 kilonewton meter, right? At D. And what should be the bending moment at B? Here it should be
0.
0. Okay. So that is how you conclude whether it is 0 or not at the supports, at the end supports. Okay. So here no couple or any moment is directly applied at B. In such cases, it will be 0. Bending moment will be 0. Right. So we have also come across this calculation of bending moment and shear force values earlier also in examples what you have taken. Okay. Now mainly what I'm dealing is to find what is the maximum bending moment. Okay, I'm interested in maximum bending moment. Okay, so we did this. Plotting we'll do it, but calculation garden will take up the plotting part. Now determine the maximum bending moment. Okay, so I want to know what is the maximum bending moment here. So in this case, first let me take this shear force and bending moment plot. Let us finish this one. Okay, so what were the values? Can you give me? At A it was 190 from 0 to 190. Okay. At C how much it was? Value of shear force at C.
Left of C 130 kilonewton, right of C 70 kilonewton.
Plus 70. Okay. Right. So this is 190. And what about at D? What value you got?
Left of D minus 50, right of D minus 75.
Okay. Minus 50 and minus 75. And finally, I think here it was 165 over here. Okay. So this is the variation. Now this will be varying linearly between A and C. UDL is there, so this will be varying linearly over here. Okay, so at C when I cross that, there will be a sudden change here. Here it is 190 kilonewton, and this was 130 kilonewton. 130 minus 60, how much it was? 70 kilonewton. And here minus 50 and minus 75, right? And 165 kilonewtons. These are all in kilonewtons. Okay. So this is the variation varying linearly from this point. Okay. And then from here again linear variation. Okay. And after that, from here till here, 165. Okay, so this is the variation of shear force now. force diagram. Now, why I took this is I want to know where is the point of zero shear force. Okay, so to find the maximum bending moment, we require where shear force is zero. We have seen this condition that dm upon dx, okay, which is nothing but shear force should be zero. For what? For maximum bending moment. This is the condition what is to be satisfied. Now, where the shear force is coming to be zero, somewhere between C and D, it is coming out to be zero. Okay. Now, I'll have to find that point where my shear force is zero. Now, let us say we'll take this section over here between C and D. This is my section. And let me assume that the distance is x where my shear force is zero. Okay. So, in this portion, I'll first write the equation for shear force. So if you want to know shear force at any distance x from point A, what will be the shear force equation is 190. What are the forces which are coming to the left of this section are RA, which is 190, minus 30 UDL intensity into x meters, okay, minus this 60 kilonewton load. 60 should be equal to 0. Or this will tell me what is the point where shear force is 0. The distance where shear force is 0 here. Okay. So how much is that? 130 by 30. So that comes out to be 4.33 meters. Is that okay? What I did was I identified where the shear force is changing from positive to negative. This is positive shear force and this is negative shear force. Okay. So if you look at this is A, this is point B, C, and here is D. Okay, so somewhere between C and D, we are having this zero shear force. Okay, so wherever this shear force is zero, we will be getting the maximum bending moment. Okay, because this is the relation between shear force and bending moment. Dm by dx is equal to shear force, and for maximum bending moment, what we require is the first derivative of bending moment equation to be zero. Okay, dm upon dx has to be zero for maximum bending moment. And also what I know is dm by dx is nothing but the shear force at that point. Okay, so what I am doing here, I'm equating the shear force to zero to find out what is this point over here where my bending moment will be maximum. Okay, so I took this section somewhere between C and D at a distance x from A. What all forces are coming to the left of this section? Okay, all these forces are taken here. So VA 190 plus 190 due to UDL minus 30 into X and this 60 kilonewton load minus 60. So when I add up these things, it should come out to 0. Okay, this is the point of zero shear force. Where is that point? At a distance of 4.33 meters from A. I got this equation, the value of X from this at a distance of 4.33 meter from point A. Okay, now we came to know where shear force is 0. So at that point, our bending moment will be maximum. So what is the maximum bending moment? So maximum bending moment. Okay, so you'll have to use this value of x and find the bending moment at that point. So it will be 190 into 4.33. Okay, clockwise, it will be clockwise, minus due to UDL 30 into 4.33 into 4.33 divided by 2. Okay, this is due to UDL minus 60. Okay, into what is the distance here now? This distance between our section and 60 kilometer road, it is this distance, which is x minus 2, 4.33 minus 2 meters. Okay, so this will give me value of bending moment, maximum bending moment. Please note down this and calculate that. So how much this is the value of bending moment, maximum bending moment? So this is how we find the maximum bending moment in any beam. I wanted to make this clear because in yesterday's problem, we were not getting this condition, the maximum bending moment from this particular condition. Okay, it was because of those couples which were present in that beam near the free end. Hello, sir. ಸರ್ ಮಾಡಿಲ್ರಿ ಒಂದು ಸ್ವಲ್ಪ ಕ್ಲಾಸ್ ಹೋಗ್ತೀನಿ ಹೊಳ್ಳಿ ಮಾಡ್ತೀನಿ ಹಾಂ ಹಾಂ ಓಕೆ ಎಸ್ ಕ್ಯಾನ್ ಎನಿವನ್ ಗಿವ್ ಮೀ ಹೌ ಮಚ್ ದಿಸ್ ಕಮ್ಸ್ ಔಟ್ ಟು ಬಿ
Sir, 401.66.
Okay, so this is 401.66. Six kilonewton meter. Okay, so this is the maximum moment. Where it is maximum? At this particular point, at a distance of 4.33 meter from point A. Okay, so this is how you get the value of maximum bending moment. You will be asked to find out the maximum bending moment here. Okay, now we'll plot the bending moment diagram. A point of contraflexure has been asked. Okay, so in this you will not come across any point of contraflexure because bending moment are all positive. They are not changing any sign over here. Okay, so our bending moment, this one will not have any point of contraflexure in this. Okay, so what we have now, bending moment diagram, we'll finish with that. So this is the beam over here, and A, and this is my point B, C, and D. Okay, sorry, this is B and D. So because the entire beam is carrying UDL, the variation throughout the beam, the variation of bending moment throughout the beam will be parabolic here. Okay, so where is this? This is what? This is point C, this is point B, and this is point D, right? So at these points it is 0 and 0. What was the value at point C? I had bending moment value at point C. Here it is 320, and at D it is 360. Okay, so 320 and 360. So I'll plot these ordinates, 320 and D 360. Okay, what is the value of maximum bending moment? It was 401.66 kilonewtons. Okay, so now you can understand how to find the maximum bending moment value. We have determined the bending moment at some definite locations at point C and D. Okay, but they may not be the maximum bending moment. So in order to find out the maximum bending moment, what condition we used was dm by dx should be 0. Okay, or in other words, dm by dx is nothing but it is equal to the shear force at any point. Okay, at a point x. So we equated the equation of shear force to 0. We equated shear force to 0. So this is the point where bending moment will be maximum. Okay, so by doing that, we got the distance x where shear force is coming out to be 0. Okay, and we determined the bending moment value at that distance x. So how much is this? This is 401.66. So this is the maximum bending moment in this beam, right? So we'll be plotting these now. So I'll be giving the plotting the maximum bending moment also. So somewhere at this point we have this maximum bending moment, right? Approximately. So this is how the variation of bending moment will be, entirely parabolic in nature. Okay, this is 401.66, and what are the other two values? It is 320 and 360. At point C, 320, and 360 kilonewton meter, and this is also kilonewton meter. Okay, so this is our bending moment diagram, BMD. Okay, note that entire bending moment diagram is positive, entire beam is under sagging moment, so we'll not have any point of contraflexure here. Point of contraflexure is where the bending moment will change its sign from positive to negative or from negative to positive. Okay, so I hope it is clear about the maximum bending moment, determining the maximum bending moment. Any difficulty in this part? We are almost about to end this third module. Okay, if you have any difficulty, any repetition is required, please tell me. Please understand how we did this calculation of maximum bending moment. Okay, that is important. Point of contraflexure, in that problem we did not find any point of contraflexure over there. Okay, okay, just try with this one. What we have here in this problem is the overhang beam, overhang portion is present over here. So same thing, try to find the maximum bending moment and the point of contraflexure, and also plot the SFD and BMD. That is the problem. Reactions, go for finding the reactions. Is any difficulty for anyone? So we have VA, okay, summation Fy is equal to 0. So if I take this condition of equilibrium first, so I'll be able to write VA plus VB, okay, minus 80 into what? 8 meters. Okay, so this is should be 0, or VA plus VB should be equal to 640 kilonewton, right? I'll take summation of moment about point A is equal to 0. Okay, when you have overhang, if at all overhang is on only one side, it is better you take moment about this point. Okay, so all the moments you can consider them easily. When overhang is present on both the sides, there may be a beam with the overhang present on both the sides also. So in that case, it doesn't matter whether you take here or anywhere, because overhang will be there on both sides of the support. So what we have, VB into 6 meter, that is anti-clockwise, minus VB into 6 meter plus 80 into 6, okay, not 6, 80 into 8 into 8 by 2. It should be 0, or this will give us what is VB equal to. If you have problem in calculation of support reactions, you can ask and clear your doubts. Many of you are not able to calculate the support reaction yesterday. What is this reaction, BB?
So 426.66.
Okay, 426.67. I can write kilonewton over here. So what about VA if we get VB?
213.34.
Okay, 213.33 kilonewtons. So these are the reactions. Quickly, the shear force. We'll calculate shear force at A, B, and C. Only these 3 points. Okay. Shear force. So at A, okay, at A it will be equal to VA. So which is equal to 213.33 kilonewton. Okay, left side upward force. So 213.33 kilonewton. At B, so at B, I have this reaction. I'll be considering two sections. Before, to the left of B and to the right of B. Okay. Before I cross this reaction, the shear force is, so left of B, it will be this 213.33. Okay. Minus, because of UDL, it is of intensity 80 kilonewton per meter, and this is 6 meter length up to B into 6. So this will be the value of shear force. So this will come out to be how much will be this?
So minus 266.67.
Minus 266.67 kilonewton. Okay, and right of B, to the right side of B, it will be 213.33. Okay, minus this 80 into 6 minus VB. So 213.33 minus 80 into 6 minus VB is 426.67. So that will give us as sorry, this is plus, not minus, because it will be to the left when I cross this point B. It will be to the left, and left side upward force will have positive sign for that. So this comes out to be 213.33 minus 80 into 6 UDL downwards, plus this VB is acting upwards. So plus 426.67 kilonewton.
167.
Okay, this is 160 kilonewtons. Okay, and at point C, what will happen to the shear force at point C? When I reach point C, it will be equal to 213.33 minus 80 into this 8 meter plus this 426.67. Does it come to 0 or no? Yes, free end.
Yes, sir, 0.
Okay, so here I don't have any concentrated force applied at the free end. So it has to reduce to 0. Okay. If not, it will be equal to the concentrated load which is acting at that point, right? So now what about the bending moment values? So find out the bending moment for this beam. At A, we can conclude it is 0. No problem with that. Okay. Now at B, what is the bending moment value? And at C, what is the bending moment value? These are the points where we require the bending moment value in this beam. Okay. So I can write bending moment at A is equal to 0. Okay, this point A. And bending moment at B. Okay, this is B. I'll come to point B directly. If at all, if you are given the interval to calculate at these 1 meter interval, then go for doing that. If not, these are the points where we require the bending moment for plotting the bending moment diagram. At B, it will be this VA into 6 meter. That is, I think 213.33. 213.33 into 6 meter, and this is clockwise movement to the left of the section, so positive. So this is how much bending moment at C. So here it will 213.33. Sorry, one more is what I missed here, UDL. So this is minus 80 into 6 into 6 by 2. Okay, minus 80 into 6 into 6 by, sorry, 8 into 8 by 2. At C and at B, plus this is 400 and due to 426.61 due to VB 426.67 into 2 meters. Please calculate. Okay, these are the calculation of bending moment at B and C. At B, 213.33 into 6 meter, this VA into 6 meter, clockwise, left side, positive, minus 80 into 6 into 6 by 2 due to UDL. Anti-clockwise, left side, that will be negative. So what is the value over here? At B,
160.
160 kilonewton meter. What about at point C?
So minus 426.62.
Minus 213.33 into 8 meters. Okay, wait. This is 8 meter distance. 8 meters. Okay,
Sir, that the bending moment
Mhm.
at B is minus 160.
minus 160. So this is minus 160. All right. And here 213.33. This VA into 8 meter. I'm calculating about point C. VA into 8 meter minus due to UDL 80 into 8 into 8 by 2. Okay. And due to this VB, which is 426.67. So plus 426.61 into 2 meters. So this will be how much?
So minus 426.62.
Minus 426.62. Check once again. Uh, 80 into 8 into 8 by 2, correct?
Sir, minus 0.02.
It should come to 0, almost 0, because this is the free end over here. Okay, so even at such points, you'll get the bending moment as 0. Okay, when bending moment will be having value at these points is when you have couple applied over there, or else at such supports, okay, end supports which are hinge support or free end of the beam. At these points, the bending value will come out to be 0. Okay, is that fine? Now, what about the maximum bending moment then? We have the shear force values here. Can you tell me what is the point where bending moment is maximum? See here, if you look over here, left of B and right of B, shear force is changing the sign here, positive to negative. Okay, and okay, between A and B, 213 and minus 266. At this point, somewhere the shear force is becoming 0. Okay, just look at those shear force values, what we have calculated. At point A, it is 213.38 plus 213.33, whereas at point B, it is minus 266.67. Between these 2 points, somewhere the shear force is becoming 0. Okay, so take a section over here between A and B. Okay, assume it is at a distance x from point A and find out that. Okay, find out this x where shear force is 0. Okay, you can do this after plotting the shear force diagram or even plotting the shear force diagram, both. Okay, anything you can do. So just calculate that. For maximum bending moment, the condition what we apply is again my condition, mathematical condition is dm by dx should be 0. The first derivative of bending moment should be 0 for maximum bending moment. But what we know is this dm upon dx is nothing but the shear force. Okay, therefore what I can say is f should be equal to 0. Shear force at that point should be 0. Okay, so from the values of shear force, okay, this shear force is changing from positive to negative between A and B. Okay, so what I have, the shear force here, 213.33, okay, VA minus 80 into x should be equal to 0. Or what is the value of x from that?
So 2.67 meters.
How much?
2.67.
Okay, 2.67. You got that as 2.67. Or x is equal to 2.67 meter. So what is the bending moment at this point? Bending moment at 2.67 meters from A. That will be the maximum bending moment here. So bending moment at a distance of 2.67 meter from A, it will be 213.33 2.33. This is VA into 2.67. This is left side clockwise movement minus 80 into 2.67 into 2.67 by 2. So this will be how much? This is our maximum bending moment. So, okay, not why I wrote this 0. What is the maximum bending moment value? How much is that? This comes out to be
284.46.
284.46 kilonewton meter. Okay, so this is the bending moment, maximum bending moment, right? Which is positive here. Between B and A and B, what I got is bending moment is positive. Okay, and you see, the bending moment at C is how much? It is 0, whereas at B it is minus 160. Okay, somewhere here the bending moment is positive, at B it is negative. So we'll have a point of contraflexure here. Okay, we'll have to identify that point of contraflexure. Okay, so like we did for this shear force, for finding the point of zero phase shear force, we'll have to find the point of contraflexure by equating bending moment equation to 0. Okay, please understand and see here. What I got is bending moment at B. When we calculated bending moment at point B, it is minus 160 kilonewton meter. Okay, and when we calculated maximum bending moment, it is coming out as plus 284.46. Okay, so bending moment is positive between A and B, whereas at B it is coming out to be negative. So we are having a point where bending moment is changing from positive to negative. That is a point of contraflexure. How do you find that point of contraflexure? Where it is, at what distance it is, I have to find out that. Okay, because the nature of bending of the beam is changing over here. So again, what I'll do is I'll take a section somewhere between A and B at a distance x from A. Okay, now I'll write the equation of bending moment for at this particular section. Okay, so what will be that equal to? This is VA 213.33 into x. Okay, minus due to UDL 80 into x by 2. Okay, so this bending moment should be 0 at point of contraflexure. This is one single word actually, point contraflexure. Okay, at point of contraflexure the bending moment value will be 0. Okay, so or what I can write, I'll write a equation of bending moment at some distance x from A, because the bending moment is changing sign between A and B only. Okay, I'll write this equation and equate it to 0. That will tell me what is the point where bending moment is 0, where it is changing the sign, or where is the point of contraflexure, that will come to know. Okay, so what this will be, this will turn out to be a equation in x. So this is 213.33x minus 40x square is equal to 0. Okay, or if you solve it here, you can solve it easily, divide it throughout by x and find what is the x value. X is equal to, you'll get two value, either x is 0 or one more value is
5.34.
or x equal to 5.34 meters. x is 0 is directly at point A itself. Okay, that doesn't make any sense for us. But x is equal to 5.34 is a point where our bending moment is changing the sign. Okay, or that is the point of our contraflexure. Okay, so if at all point of contraflexure exists in your beam, that you will come to know by looking at the bending moment values what we have calculated. Okay, so if the bending moment is changing from positive to negative or negative to positive, point of contraflexure will exist in that beam. Okay, so you'll have to find the distance where that point of contraflexure lies, or where the bending moment is changing its sign over there. Fine. Okay, we'll stop over here. Try to draw the bending moment and shear force diagram for this beam. Okay, maximum bending moment we have calculated. The distance of point of contraflexure has been determined. Okay, what we are left is drawing the bending moment and shear force diagram. Okay, try that one. As per the signs, you have to plot the ordinates and connect them. Please put your USN in the chat box for attendance. I mainly wanted to bring to your point the calculation of maximum bending moment and determining the point of contraflexion in these problems. I'll not share the yesterday's video. We have just discussion and just we have stopped over there. This will be shared later. You can leave the meeting after giving the attendance.